So everyone can see the screen properly? It's good? Okay, perfect. So welcome to the Zero to Data Advanced workshop today. My name is Santiago. I'm the developer relations for web3.js. Thank you so much for coming. I know that some of you are coming from really far places and it's kind of early as well. So yeah, I really appreciate that you come today. I think this is one of my favorite workshops. I had never done this one before specifically. And maybe at the end I will improvise a little bit to teach you some things. The main idea with this workshop is that you will be able to learn about Web3 plugins. And the idea of learning the Web3 plugins, not to use them, but you will also learn how to use them. And the bounty for ETHAccra is about using it. But then I will teach you today how to make one, how to build plugins. And I think this is really useful for you guys because you can apply for any plugins in any projects, any protocols. You can build a plugin for them, and maybe you can get like this type of grants for developer tools or whatever. So yeah, basically today you will learn how to build some developer tools. I will tell you what is the Web3 plugin, what you can do, some examples of the Web3 plugins that already exist, so you can get an idea of what you can do with these plugins. If you have any question, if you are confused, if something is not working, let me know, and we can like stop. Because we are not like a huge group, so that's better. So I can make sure that everyone is in the same page, and we are just like going through together. And the idea is that everyone will be able to deploy their first Web3 plugin today. Okay, perfect. So the one that I will do today, my idea is to do 2 plugins today, or maybe even 3. Let's see about the timing. But the first one is about interacting with some layer 2s. Who knows from here what is the RPC communication protocol? Do you know what is the RPC? Yeah? Who don't know what is the RPC? Everyone knows RPCs. Yeah, okay, you don't know, perfect. I will show you in the next slide, and basically the RPC is like the language that you need to use to speak or interact with the Ethereum or any like the Ethereum virtual machine. So when you're interacting with Ethereum, how do you use, I don't know, with web3.js, ethers or VM to interact with Ethereum? Like for example, to get the block number, have you used that before? No? Okay, so normally, let's see if I have that here. Normally to interact with that, let me show you something really quick. Maybe this one. I want to make sure that everyone understands, so maybe we'll do some pauses so everyone can understand this too. So basically, when you are interacting with Ethereum, so basically, when you are interacting with Ethereum, what happened? Yeah, what happened is that you are sending this RPC call. So this is an RPC call, and you can see that it's just like a mess of text, right? But then when you use web3.js, this is what you are using. So at the end, you are using web3.e.getBlockNumber, and then in the like under the hood, web3.js is sending leads to the blockchain because this is an RPC call, right? So basically, every time that you want to interact with Ethereum or any EVM blockchain, you are sending RPC calls. If you want, you can check the Ethereum RPC API in ethereum.org, and then here you will see all the different like RPCs that you have. This is really important to understand today. I mean, we don't need to understand everything, but at least the high level of what is the RPC. So when you're trying to get the balance of an account, what you are doing is basically sending this RPC that you see here, but with the method ETHGetBalance, right? So that's basically the RPC API, just sending a bunch of different types of methods, the same here. If you want to get the storage, if you want to do these type of things, that's what you're sending. So when you're sending a transaction, the same, you're just sending ETH_send transaction, or when you want to sign transaction and things like that. Everyone understand what is the RPC API so far? Here? Yeah. Perfect. What happened is that Ethereum, it has like the Ethereum JSON RPC API, right? But then there is a bunch of new layer 1s and layer 2s that they create new technology, CK, whatever, and then they come with a different RPC calls, right? And then what happened is that these RPC calls are not kind of made by default, that you can interact with them using web3.js, ethers, or any JavaScript library. So then what we are going to do today is how we can wrap these RPC calls into a plugin. So we can make, for example, a web3 plugin to interact with CK Sync or with Arbitrum, or with StarNet, or with Polygon CKEVM. Because these chains that we have here have different RPC calls. They have the Ethereum ones, but then they have even more, right? So when they have even more, that's just like a mess for the developers to interact with those chains, right? So then today we are going to learn how we can create like a plugin to interact with different RPC calls. If we have some time, I want to create 2 more plugins. One to interact with the RPC calls of MetaMask, so we can create a plugin for the front-end developers. And then one for Chronicle Oracle, so we can create a plugin for interacting with Oracle. Something similar to what we did with Chainlink last Saturday, but actually creating the plugin. So yeah, this is what we are going to learn today, JSON RPC API, and then how Web3 plugins can make our life kind of easier. This is what we are going to build today. So this is what I just said, that this is the JSON RPC API, right? So this is what we are sending all the time. This is what you need to do using web3.js, like to do this. But then we are going to create a plugin where we are going to wrap this into a plugin, so the developer only needs to use this function that you see here instead of writing these things. So that's what we are going to do today, to kind of wrap these things into this, and then kind of publishing this also as an NPM package so everyone can use it. Yeah, this is kind of the cover of today, the agenda of today. I'm going to start with the Web3.js intro, maybe a little bit quick because I guess most of you know what is Web3.js. Then we are going to start with the Web3.js plugins, a little bit like the concept of what is a plugin, how we can use them. Then we are going to build a plugin. I'm going to show you some existing plugins. And then if we have time, we are going to build 2 more plugins, hopefully. But yeah, I will go slow so everyone is able to go to be in the same page. Yeah, for those who don't know what is Web3.js, I just kind of show you. So Web3.js is just like an abstraction over all these RPC calls that we have here into this. So if you want to interact with any contract or whatever, we are just making it way easier in JavaScript instead of the developer sending these weird RPC calls. Yeah, same here. This is how you interact with the smart contracts. Who knows what is in the data field when you interact with the smart contracts? Do you know that? Maybe that's a little bit advanced, but that's a good thing that's out of the workshop. But if you learn that, I'm sure that will get you a job if someone asks you. Do you know what is in the data field when you send a transaction? No? So? Opcodes? VA. Okay, that's kind of getting really close. Normally, when you send, let me just show you really quick. This is really useful for you to learn. Not part of the workshop, but I know that it will help you a lot. I did this for my first job as a DevRel, and I learned a lot about that, and it was really useful. Maybe it's here. Yeah. Okay, so when you are sending a transaction, we have different fields, right? We have the from field. So the from is like the address that is sending the transaction. We have the to. So these two, that can change. That can be the address. So for example, if I'm sending one ETH to Kwaku, so here in the to will be his address, right? But then if I'm interacting with a smart contract, the address of the smart contract will be in the to field, right? So that's a really good thing to learn today. If you're interacting, sending value, or if you're interacting with a smart contract. That's the change. Then the value, in case that you are sending money, then you will have the value here, the value field 0 or 1. Then here is the tricky thing. So the data, when you are interacting with a smart contract, you can see all this weird thing here. I think I have it in some nice colors here. Give me a second. So I'm going to show you what I mean. Yeah. So for example, when we are interacting with a smart contract with an ERC20, let's say we are going to send a transfer, right? Everyone knows ERC20 token, that it has the transfer function. Yeah, I think yesterday you saw that. So we are calling the transfer function, and then we need to send 2 parameters. Recipient, right, the 2, and then an amount. So what happened is that in the data field of the transaction, we are sending 3 things. The first thing is this green, and this is called function selector. Who knows what is a function selector? No one knows what is a function selector. Perfect. So I'm happy, you will learn a lot today. So a function selector is, you need to hash the function, which is transfer address to uint 256 with the key check 256, and then you take the first 4 bytes of that whole, because remember that is like 32 bytes, if I'm not mistaken, and then you only take the first 4 bytes, and that's the function selector of the transfer function. So basically just the key check of this thing, transfer address to uint, and then you only take 4 bytes, 0x, and then you see A9, 05, 9CBB, that's 4 bytes. Remember that 2 bytes, yeah. How is it? 2 bytes. 2 characters are 2 bytes, 1 byte, yeah. So they have 1, 2, 3, and 4, yeah. And the 0x doesn't count as a byte, that's just for the hexadecimal value. So first in the data field, we have the function selector of the function that we are calling in the smart contract, right? Is that clear so far? We are calling the transfer function, and this is the function selector of the transfer function. Then here, let's see if I have the colors. Yeah. Let's see. Yeah. Then the yellow thing is the address that we are sending like we are making the transfer, right? What happened is that the address is 20 bytes long, right? So that's why you see the address here, 832 blah blah until here, and then we just need to path everything to 32 bytes with zeros. So that's why we see a lot of zeros, and then the address that is here. And then after that, we have the amount. Let's see. Yeah, the amount, which is only 1. I'm just sending 1 token, and then the rest of bytes will be 0 because it has to be 32 bytes length, right? So basically, this is the magic of the data field, that you always have the function selector, and then the parameters, you need to encode that and path that to 32 bytes length, right? Let's say that the transfer function doesn't have any parameters, any arguments, so you are basically sending in this transaction only this. And then you don't need to send any of that. And then what we are kind of sending the transaction is call this smart contract to this function. And then it will just kind of return. But this is basically when we are sending transactions to interact with the smart contract, this is the data field. So it's really important to understand the data field. That will just make you a little bit more fancy developer, more pro to know about the data field. Is everyone able to understand the data field concept?
Yeah. This is the function selector aspect. So what exact function is it selecting?
Is this one. So basically what you are doing, let me see if you have like a big example here. Just wanted to show you, it's easier to understand. Yeah. Yeah, so normally this is the code when you want to get the function selector. In this case, there is like no parameters here, but you are doing the keycheck 256 of the function. In this case, look at the function here, transfer, and then you just send the address and the uint here. So you are putting this part that you see, transfer address uint 256 here, right? And then you are just doing the keycheck here. The keycheck, you know what is the keycheck? Have you used this keycheck before? Yeah, that's a hash. Oh, okay, perfect. So let me just tell you real quick. So let's say that the keycheck 256 is a way of hashing. It always have an output of 32 bytes. So you can put whatever, let's say Santiago, and then as you can see, we will always get a 32 bytes length string, right? Or I can put Jesse or whatever, and as you can see, it's just a different thing. And this hash, supposedly in theory, it never clashes with anything. So it's impossible to find 2 values here that will produce the same output. Is that clear with the hashing, with the keycheck 256? So the function selector is basically doing this, transfer address uint 256, and then you see that the output is this whole thing, right? But then we are only getting the first 4 bytes. 1 byte, 2 bytes, 3 bytes, 4 bytes. And then if I come here again, we can see, I will copy paste here. As you can see, we have here the 4 bytes. A9059CBB. And then if we check here is A9059CBB. So now you know what is the function selector.
So basically saying you're selecting the transfer function.
The transfer function in this smart contract that we are calling here. Yeah, and then if you go, let's say ERC20 interest scan, USDT interest scan. Here we can also see the function selectors. So if I come here, they are showing the function selector here. Okay, some of them are showing the function selector. Normally it shows, but I don't know why. Oh yeah, here it is, right? And then transfer, yeah, look, perfect example. Transfer function selector is 0x A9059CDD. So that's the function selector of the transfer.
Okay, so these are different function selectors you can input into. That would mean the data field when you are transferring. Based on what exactly you're doing, whether you're posting, issuing, setting parameters.
Yeah, but for example, the transfer function will be the same function signature in all the smart contracts.
Okay.
The only thing that will change will be the smart contract that you're calling. Right? So in that way, the Ethereum virtual machine knows which smart contract you're calling. Because you're sending the address and then the function selector or the function that you want to interact to. Yeah? Perfect. Is this part clear of the data? The data field? Perfect. Now you're experts in Ethereum transactions, which is great.
One last question.
Oh, I never record my screen. Let's record now. Yeah?
So as you can see, for the video you just showed,
Yeah.
it says for the address in the form, is that your address?
Oh wait, let me just do it again. The address in the front field. Yeah.
It's your
Yeah. That's the address that is in the transaction. So that's your wallet.
and then the 2 is
The smart contract address. This 2 here is the smart contract address. But then in the function is the, let me see. Yeah, so we have, let's say 2. These 2 and these 2. Right? What happens is that this 2 has the smart contract address and this 2 is the address that you're sending the USDT or the USDC because you're interacting with the token. But then this 2 is the address of the USDT. Right? Is that part clear? Because yeah, we have 2 2s here. But then if you're sending 1 ETH, let's say here we will have 1 ETH, so then this 2 can be my address because you are going to send me 1 ETH.
But how come it says value here is 0 and in the value is 1? You said the last
Yeah,
one.
because this value, okay, that's a good question. This is the amount of tokens that you want to send, so the amount of USDC, right? But you want to send me only USDC, you don't want to send me ETH, and this is to send ETH. This value is to send ETH because ETH is the currency of the network, right? So every time that you want to send the currency of the network, this is the value that you need to touch. But if you are sending tokens, this value can be 0, but then this value will need to be the value that you want to send. Is that clear? Perfect. Any questions so far? This clear for everyone? Okay, perfect. Okay, so now we know all the different things of the Ethereum transactions, right? So this is how we interact basically with the smart contracts. Can you imagine if you need to send these things manually? That would be a mess. So that's why with web3.js, you only need to type the contract.methods.transfer, and then you put the 2 and the amount. And we don't need to care about all this data thing that I just explained. But anyway, I'm explaining that to you so you know how everything works, right? Also, you don't need to care about the gas price, or whatever, the nonce. Everything is kind of under the hood. Perfect. Web3.js has a modular design, so it has different packages. When you install npm install web3, you are basically installing this, and this is installing all the different packages, right? But then if you want to use specific things, for example, the contract, because you want to interact only with the smart contract, you can only install the npm install web3-it-contract, and then you will install that specific package. And then the package that we are going to use today is the web3 plugin base, so we can develop web3 plugins. Yeah, for the ones who don't know, this is basically a dApp communication flow. Web3.js is here kind of in the front end of the application. Then Web3.js will connect to an RPC endpoint. This RPC endpoint is just like a URL. And then this URL, this RPC endpoint, can be QuickNode, Infura, Alchemy, I always use chainlist.org. This will talk directly to the node in the blockchain, and then the node will retrieve the information or will execute the transaction. If you have any questions, while I'm speaking, feel free to just raise your hand and it will be fine. Web3.js is compatible with all the AVM blockchains. So yeah, Ethereum, Avalanche, Silo, Optimism, Polygon, etc. There are more than 300 blockchains. You just need to change this link that you see here, this URL. So basically, to start using Web3.js, we just need to look at this slide. We need to start installing npm install web3, right? As I have here in my shirt. Then after that, we can import the web3 module. This is important. The Web3 must be within the curly braces and then the W uppercase from Web3. And then we initialize the RPC endpoint. So remember, the RPC endpoint is what I mentioned here. So depending on the RPC endpoint that we initialize Web3 with, we are going to talk to a different blockchain. So in this case, I initialize the RPC endpoint talking to the Ethereum mainnet, but you can also put here a Polygon RPC endpoint, and then we are going to talk to Polygon or to Zillow or to any other EVM blockchain. And then after that, we can use this web3.eth.getBalance, getBlockNumber, or any other functions that you want. And yeah, that's basically how you use web3.js. Any questions here so far with web3.js? Perfect. Okay, now let's put this more interesting. So the Web3 plugins are like scalable, reliable, low maintenance SDKs that you can create for any Web3 project. That's what we are going to see today. Some of the use cases, the main ones are oracles, DeFi gaming. I would say layer 1s and layer 2s are really good, and also oracles. So today we are going to build one for layer 2s and then one for oracles. I will actually skip this. This is just different plugins that we have, but yeah, that's not really important for today. And now let's get started with this. Perfect. So I'm getting hot now. If you get really cold, let me know. Then I can, maybe like you three here. So yeah, this is what we are going to build today. A plugin that can interact with these different networks, right? Because these are like the main Ethereum JSON RPC APIs that are already kind of built in Web3.js, but these ones are not built anywhere. Because when you are making a, let's say we are fetching the gas price, we are making this call, ETH gas price, right? But then there is no like RPC implementation for these specific RPC codes, like startup underscore chain ID or CKS underscore get fee params or CKVM, etc. And there are even a lot more. But yeah, these are like only for the scope of the plugin today. So now let's get started with this. First, we are going to create a node project. So let's open this, local VS Code. I'll try to go slow. Yeah, because it's different. Normally the questions that I do are always like in the events that you just do it, you just show it, right? But these are better because you're actually people following you line by line, so that's even better. Okay, so I will create a folder. Let's call it 0 to nav. Okay, what I'm going to do here is creating the folder that I'm going to open this folder in VS Code. And as you can see, we have nothing, right? It's empty. To create a node project, the first thing that we need to do is npm init-y. Then you will see the package.json here. Then we can install web3.js. Then we can install web3.js by typing npm install web3. I'm sure you will never forget that npm I web3. It's really memorable. And then you will see the web3 library here in the dependencies. Perfect. So as you can see now, we installed the web3 library. And now let's jump into the fun part that is creating the plugin. Let me show you this. I hope my computer don't crash with the recording. Okay, so to create a plugin, this is kind of the template. The first thing that we need to do is to import the Web3 plugin base module from the Web3 library. Then we need to create a class which extends from this Web3 plugin base that we have. Then after that, we need to add this property plugin namespace, because this is the name that the developer user will use to interact with the plugin. I'm going to show you that. And then we are able to start interacting or creating different implementations, different functions, whatever. Send transactions, deploy contracts, interact with different contracts, listen to events, fetch data, send RPC calls, whatever. Some even really good use cases that you can do is that you can also install other libraries, so then you can extend the Web3.js functionality to do something else. Like a really quick use case is, let's say you can install the Google API, and then create a Web3 plugin that can listen to events and then put all the events of the blockchain in a spreadsheet, for example. This is like creating a Web3 plugin with the Google API, but yeah, the ideas of creating Web3 plugins are limited. You can literally do whatever you want. So let's start creating the plugin. So I will just create like an index.mjs file here. Yeah, then import Web3 plugin base from Web3, the first step. Something important that I will do it right now is in the package.json, we have a main field here that is pointing to index.js. But because I call it MJS, so I just need to change this to MJS. Perfect. That's a little thing that you need to know. Yeah. In the package.json, we have this main field. This main field, because when the developer installs this plugin, and the developer calls the plugin will kind of use this package.json main to look for this file, to kind of tell like, hey, here is the code that you're calling. But because it's by default index.js, but I created for example.mjs, so then I need to change this to example.mjs. So this main should be pointing to the file where you have the plugin, right? So if you call this in a different way, make sure that the main package.json is pointing to the same name. Is that part clear?
Yes.
Perfect. Let's put index.mjs. First thing, import Web3 plugin base. Second thing, create class, right? So I'm going to directly kind of export the class here, so I will just type export default class, and then we can put any name to this plugin. Let's call it 0to-that. And then remember that the plugin needs to extend the functionality from the Web3 plugin base. Perfect. So far we created the class, which extends from the Web3 plugin base. Perfect. Then after that, what we need to do is remember that we need to create a property that is called plugin namespace. When you just type plugin, you will see that this comes up automatically, plugin namespace. When I'm using JavaScript, you can also use TypeScript, which will be even better and easier, but yeah, just to get started, it's just better to do it with JavaScript. Plugin namespace, let's call it advanced. Or advanced track.
So just to get clear, plugin namespace is the name.
Okay. Let me
That's the name you assign.
Let me tell you what it is. So what happens is that at the end, when a developer will install the plugin, they will use the plugin in this way. Web3 dot, this will be like lowercase, Web3 dot advanced track dot function, right? So then here is this name of the plugin namespace. So if I call it, let's call it ACRA, that will be easier. So if I call it ACRA, it will be web3.acra.function, right? So that plugin namespace is the name that the developer will use to interact with our plugin. So yeah, let's just call it ACRA. That will be easier. Perfect. Is everyone in the same page right now? Any questions? I saw you were late. If you want, are you going to code as well? And to follow along? I can repeat some of the things if you want.
Can you go up to the example you gave?
Here?
Yeah, when you just type it.
It would be like web.acra dot do something. Like here we will have like, we're calling the function. Yeah, that depends on the name that we have. Right? Yeah. So yeah, just to kind of wrap up this so far, we just installed the Web3 library. to send a transaction, your address, to a specific address, that is this 0xC8, but you cannot interact with this address like if this is a smart contract. So this address is only accessible via RPC calls. So they have, let's say, like a smart contract deployed in Arbitrum, but you cannot interact with that smart contract from other smart contracts. The only way to interact with this address is via RPC calls. So that's why this plugin can be really useful for Arbitrum, because maybe they even also have their own SDK, I don't know, but we are kind of creating a SDK to interact with this node interface reference, which is only accessible, as you can see here. This is only accessible via RPCs. It's not actually deployed on chain, and thus can be called by smart contracts. That's why this is a really good use case for the RPC calls. So in this case, also I will share the slides. Maybe I can share the slides now. You want me to share the slides now? Yeah, that would be really useful, right? I will publish that in Santiago at Santiago.rel. Okay. So what we need to do is how we can send an RPC call with web3.js. That's what we need to learn first, right? So remember that RPC call always have two things, something called methods and parameters. I'm going to show you really quick here. Maybe this example is better. No, yeah. So I'm just going to show you how a RPC call is kind of constructed. So as you can see, this is a RPC call, and we'll always have two main things: a method that we are calling, and then the parameters. Those are like the main things that we need to send. So to make a RPC call using web3.js, like a custom RPC call, we need to type this. Let's start with Arbitrum. We need to type this .requestManager.send, and then we open here the parentheses and then the keys, and then method and params. I'm going to do it a little bit more slow, and I'll explain too. So in this case, this is kind of the context of the plugin, but if we are using that using the normal library, here you will just need to type web3.requestManager, etc. But because we are building a plugin, that's why I type this, right? So this .requestManager.send, then parentheses, and then the curly braces, method and params. So this is how we can send any RPC call, like a custom RPC call, to interact with any blockchain, right? In this case, the one that we are using is ETH_call. This one is implemented by default, but remember that in Arbitrum it's like a really specific use case, so that's why it's different. It's not making a normal call. I will just wait for you till you are here. Is everyone here so far? Yeah. Perfect. So here is the tricky part. We need, in these patterns, we need to send an object with these two different fields, because we are making a like kind of sending a transaction or sending a call. Yeah.
So the method, just wanted to confirm, it doesn't mean to be trying to make simpler for Arbitrum. What exactly is the method?
The method is like the JSON RPC API that we are calling. in this case is a call. A call is a method to just fetch data from a smart contract. So if you're calling, for example, let's say the USDT here, and you want to get, let me show you. A smart contract always have two types of functions, writing functions and read functions, right? So if you are going to interact with a smart contract with a read function, you're actually sending an ETH call. And then in these two, it will have the address of the USDT, right? And then in the encode function signature, it will be, let's say, name, right? And in case that we are calling the name of the USDT, right? But in this case, we are interacting with this nitrogenesis block in this specific address, which is the 0x00C8 in Arbitrum. That's why it's different, the use case. But every time that you're interacting with a smart contract, this is what's happening under the hood. We are making an ETH call, and then in the parameters, we are sending a to address, which is the address of the smart contract, and then the data. Now you already know what is the data, like the function signature, the function selector. But yeah, that's why we use web3.js to do that encoding here. Okay, so now the patterns here, we can open the curly braces, then to, and then the data. So for the two, what we need to do is to use the web3.js. We can actually, you can copy paste this directly. It's just like an address with 20 bytes length, but ending in 08. And if you want to use web3.js, I don't remember that right now, but I think we can use the utils package. To use the utils package, you can actually import the utils package from here. So I will just type .utils, utils, and then we are interacting with the utils package as well. What I'm going to try to do here is utils, I think this is encode path left, I guess. Path left. Yeah. So what I'm trying to do here is using web3.js, so you don't need to hard code this 0x0000, but actually you can use the web3.js library to do this. So you will use utils.pathLeft, then we can send 0x, just check again. Yeah, 0xC8, because this is the address that we are interacting with, right? 0xC8. And then here, the characters. So I think that will be, how many zeros we have here? Let's try with 20. I think it will be 38. That's my head time. How you doing? Yeah, for sure, that's fine. Yeah.
I'm sorry that I'm late, like I got.
Don't worry, everything's perfect, yeah.
In the police control.
Oh, that's fine, yeah. So feel free to, yeah. Now let's stop. And let's
Yeah, sorry, just one second. So I'm here, like that room starts to fill up. I don't want to actually kind of drag you away from Santiago's presentation, but I will start in 10 minutes with the graph basics. But if you're into what Santiago is telling, I assume you are, then feel free to stay, because I will do another session in the afternoon at 1, and I will do like a quick intro to the graph also. So don't feel bad if you're interested in the graph in staying here. It's very important. Like if you really want to feel this, then please stay. If it's anyways if it's too complex, I would understand too, Santiago. I think would understand too. Okay,
yeah, for sure.
So in 10 minutes, let's start.
Amazing.
I suggest to stay here.
Thank you. That's fine. Don't worry. Yeah.
So because more and more people come in, and then I will start with the subgraph basics. But just that you know that this happening.
That's fine. That's fine. Yeah. You're also welcome to go there. No problem at all. Also, we are recording this actually.
Okay, cool.
It will also be uploaded.
So I will catch up later.
Yeah.
Okay, thank you.
Yeah, that's fine. Okay, so now, yeah, that's what we are doing right now.
Does it say 40?
Because it's 20 bytes. The address is 20 bytes length, but 1 byte is 2 characters. And then here, I think it's 38. And then here we are putting the character amount. So we are 32 will be 19 bytes. 38 will be 19 bytes. This is basically saying this. Like we have this 0xC8, and then just put 38 zeros here. This is what this function doing. I will need to check. No, it's not. It's 18. I think it's 18. It's 18, yeah. That's what I want to check right now. Yeah, let's actually check this. So what I'm going to do to check this is I will comment this function here, and then I will just type this here. You don't need to do this, but this is just to make sure that we are doing the right thing. So I'm just going to console log this result to see if this is right. And then I'm going to usage.mjs, and I'm going to import the plugin. So import 0 to that from index.mjs. Then import web3. This is how the final developer will use the plugin. We are going to do this at the end, but this is just for quick testing. That's why I'm going a little bit fast here. And then here we're going to use web3.accra. I guess it will be like that. Hopefully it will work. So node usage. Ooh, okay. This is 18. No, I think that it will be, that's too short. I think it's 38. Yeah, this looks more like an address, yeah. Actually, we just can copy paste this to make sure that that's the same. Oh, so it's 40 actually. Oh, okay, now I know why. Yeah, we are not saying add 38 characters, but actually the length string. So we want to say like the total string will be 40 characters. So yeah, 40 characters in total, the length. So that's why it's 40 instead of 38. So not adding 38 zeros, but actually fitting everything into 40 characters, yeah. That's why, yeah, perfect. So now we know that this is like this. Now we know that's how it works. Perfect. So here, utils.addLeft 0xc8. This is the address that we are like sending the RPC call, and then 40 characters. Total length, right? Remember that this is something like this. Perfect. Any questions so far with this utils thing? Clear? Amazing. And then in the data, we are calling a specific function that is called nitrogenesis block. So this nitrogenesis block, we don't really need to know what is that doing. We don't really care about what is that doing or why it's important, but just to know how we can call it. So this just returns the first block produced using the Nitro code base, and it will be the same for the other ones. If you want to make an SDK for the Arbitrum node interface, this is how you will do it, but implementing all of the other functions, right?
So all of these functions can
be wrapped into this.
Okay.
Into this. But for today's example, we are only using the nitrogenesis block. Because I will do the same for StarNet, I will use one function for every network, so you will be familiar how to interact with different networks. Yeah.
But I think all these functions, they do have plugins already.
I don't think so. I don't know if Arbitrum will have an SDK, but so what is my idea? For example, you learn this, you go and you check. I don't know if Arbitrum has an SDK for this or not. Yeah, so they have an SDK, but that can be an SDK to depending on, I don't know what you can do. Because the SDK can do a lot of different things, but I don't know if interacting specifically with this. But then my point is, maybe you learn this, and then you can check, okay, their SDK is not interacting with this Nitro node interface. So maybe I can try to do one and apply for a grant in Arbitrum, and maybe they can give you something because of that, right? Or the same with the other ones, or for any little thing. For example, I participated in May in a hackathon, and I built a web3.js plugin that allows you to, it was like doing some calling, let's say the last 200 blocks, or the last X amount of blocks that you want, and then giving you the average of the gas price, and then allowing you to choose if you want to send the transaction now, or when it's a certain limit. So because I make this plugin for that specific hackathon, I won the hackathon. So you can also use this to do developer tools for specific projects in hackathons, which is really useful as well. That's why I think this is a really nice workshop for you guys. Okay, so what we need to do here is to encode the function signature. And then to encode the function signature, first we need to import the ETH package here. And then we can use eth.api.encode function signature. And then here in the parentheses, we're sending as a parameter the function that we are calling, which in this case is nitrogenesis block. here. But then let me do something so you know what we are calling here. I'm going to also console log this. And console log this. So you're also understanding what we are doing 100%. Perfect. So I'm going to show you what we are basically doing here. Node usage. So what we are doing is sending a transaction, in this case is a call, because who don't know the difference between calls and transactions? Everyone knows the difference? Oh, okay, perfect. Important to know. So when you're sending a transaction, you're using the method ETH send transaction. So when you're making a call, you are sending the method ETH_call, right? And the main difference is that the ETH send transaction will change the state in the blockchain, will do something. Let's say we'll interact with a smart contract, or we'll send value, like we'll send ETH from one account to the other one, but you are basically doing an action, something that is changing the state in the blockchain. And changing the state in the blockchain can be interacting with a contract, sending value, or putting data, or whatever. So that's a transaction. But then a call is that when you are not changing anything in the blockchain, where you are just retrieving information. That's the thing. And for making calls, you don't need funds, you don't need money. But for sending transactions, you will always need funds in your wallet. So that's the main difference. In this case, we are making a call, so that's why we don't need any funds. And then this call will have kind of the same structure of a transaction, from, to, and everything. Okay, we will not have from, because we don't need a from address, because we will not get any funds. But it will have the to, and then remember that this to that we are calling is the 0xC8 address that we have here. And then the data, the same thing with the transaction that I explained earlier, the function selector. This function selector is the 4 first bytes of the ETHAccra 256, like the thing that I explained. Let me show you again here. If we go to ETHAccra 256, and then we just input this nitrogenesis block. This is the ETHAccra 256. Remember that it will always give us an output of 32 bytes, right? And then we just add the 0x in the beginning. But then the first bytes of this is 93, A2, FE, 21. And then if we check here, we have that, right? So basically we are saying, call this smart contract, 08, and interact with this function. So that's how we interact with the smart contracts with specific functions. Is this part clear? Yeah?
So, retrieving information from the network is called. Then what if you are changing the state?
Transactions. So performing transactions or performing or making calls. Yeah, making calls or sending transactions. Those are like the two. Basically, those are the only two things that you can make in a blockchain. Send a transaction or make a call. The call is free, yeah. Perfect. Something else? Everyone is on the same page so far? Amazing. Yeah, so I just console log this for you to know what we are doing, what we are sending in this RPC call. Okay, and this will return, if we check here in the arbitrum documentation, this will return the first block produced using the Nitro code base, right? So then this will return something. So if that is returning something, what we need to do is to put here await, and then we can store the result in here, in this the result variable, right? So we are sending this RPC call, we are storing that in this result variable, and then we can just, I will actually just console log that would be easier. Console log results. Perfect. So this is basically how we make the first one, like the first, how we implement the first function. Any questions so far with this? Amazing.
Question.
Yeah.
So it means you are retrieving a call from the Genesis block.
This is the function that we are calling. We are not calling the Genesis block, we are calling this address, but the function is called nitrogenesis block. But that's just the example of today. But for example, we can call different functions. We can call get element confirmations. So instead of this Genesis block, you can just put get element confirmation, send this, the block hash here, and then it will work. The difference is that you will need an API to do this, but yeah, that's kind of the same thing. But yeah, that's what we are doing, calling this address, this function. We are not calling the Genesis block, we are calling this address. But the function is called like this, right? And then this will just return the block number of the Genesis block, something like that. That is here in the implementation. So we can test this, right? Now you know how to test it. We will just, let me just put this in the comments so you are also testing at the same time. So we need to import the Web3 model. Remember, import Web3 from Web3. We need to import the plugin, which is in this 0 to dApp, in this index.njs. So that's why I'm importing the 0 to dApp. Then we need to initialize an RPC endpoint. So something really important is this endpoint, remember that will give us the blockchain that we are going to interact with, right? So if we send this call to Ethereum mainnet, it will give us an error. So we need to send this to an Arbitrum endpoint, right? So to send that, we are going to check the slide 24, and we have different RPC endpoints that I have here. So you can just copy paste this Arbitrum Llama RPC here. So this is how the developer at the end will use our plugin, right? He will need to do this. To import the plugin, to import the web3.js library, he will need to initialize an RPC endpoint to kind of tell web3.js like, hey, interact with Arbitrum, right? This is how we do it. Remember that you can also put here Ethereum or mainnet, I don't remember how it's called, and then we are saying like, hey, interact with mainnet, with Ethereum. But in this case, for this first example, we are interacting with Arbitrum. Then we need to register the plugin. To register the plugin is web3.register plugin, and then we just create a new instance of the plugin. This is just to kind of give the current context to the plugin, and then we can use the plugin here. So let's see if this works. So I will just run node usage. Okay, and then as you can see, this is the result that we get. This is what is returning. And maybe we can use, I will try to put this a little bit more beautiful, maybe utils dot to big int. Maybe that's not the right function. Oh, okay, what happened? Okay, this happens when you're using free RPC endpoints, like I do all the time. Then we can get errors. So we can just go to chainlist.org and we can look for another free RPC endpoint. So if you have an account in Infura, QuickNote, you can go there too. But I will go here, Arbitrum 1, and then I will check just whatever. Yeah, because maybe we are sending the call at the same time. So maybe we are saturating or square 4. Let's use this one. Perfect. So now I just returned the result in big int, which is a little bit easier to read. To do that, I just wrap the result into this utils.bigint, and then we are kind of parsing the result from this hexadecimal string into a big int. Perfect. Let me just kind of show you the code again, and then let me know if it's not working, and then I can go and check. Yeah. Oh, and it's fine. Either is that one is the one that didn't work, but it didn't work now. But you can try it 1 second and then it can work. That's just weird. But maybe we just send the call at the same time and it didn't work. But maybe you can use this one, or either will work. It will be fine. Yeah.
Yeah. Yes, I'm guessing it should be possible to initialize RPC inside of the plugin.
That's a good question. That's what I will do in the other ones, but yeah, if you want to initialize the RPC, the issue is if you initialize the RPC, then you need to have like a limited RPC, because if 100 developers use your plugin at the same time, that RPC will break, right? But then if you want to initialize the RPC, that's really good. You can also put this dot set provider. And then we can initialize the RPC inside the plugin here. And then we can just send here this arbitrum. Yeah, and then in this case we are initializing the RPC endpoint inside the plugin. And here I'm not initializing anything. And then if we run this again, it worked well again. Perfect. Any questions so far? Is everything working? Let me know if it's not working and I can go and help you.
So maybe you can even check if the user is connected to the right hand.
Yeah, you can make like a check here that is connected to Arbitrum directly. Yeah, that's true. Is it working for everyone? Perfect. Okay, so now let's implement. Actually, let's just do one more RPC here. There's no need to do the four of them. The four will be basically the same, and then I want you to also learn the MetaMask or the Chronicle, and so because they are like even more useful as well. So I want to cover more things. Choose one of these RPC: StarNet, CKSync, or Polygon CK EVM. Any preference? StarNet. Perfect. StarNet is really easy. So I'm coming here to the reference of QuickNode, and then look at the StarNet JSON RPC API. So as you can see, the StarNet don't start with eth_. It's actually starting with the StarNet_. So StarNet_ specs version, get block with TX hash, get block with TX, etc. So all these RPC calls that you see here can be wrapped into the plugin. But for the example of today, we are just calling the StarNet_chain ID. So this chain ID will only have the method StarNet chain ID and no parameters at all. So to do this, we are coming to the plugin again. We are going to a StarNet, the StarNet function, and then the same thing. To send the RPC is this .requestManager.send, parentheses, curly braces, and then method, and then params. So this is how we send the RPC calls. Remember that the method in this case will be the StarNet_chain ID. The params is 50 in this case, but some of them you will need to put something here, as we saw in the arbitrum, for example. This is a really easy one. Then await. We can just store this in this variable result, and then console log. StarNet chain ID result. Perfect. Any question with this one, with this chain ID? Perfect. This will just return the chain ID of the StarNet. Also in the raw format, which is a hexadecimal value, you will see, and then we can just change that to big int as well. And then to use it will be the same. web3.accra .starnet. We just comment this. Oh, okay. We are going to get an error now. The error is we are initializing this with the Ethereum RPC endpoint. So basically, we are sending the StarNet chain ID to the Ethereum network, and I just want to show you the error because when we don't initialize an RPC here, this is mainnet by default. Mainnet is the Ethereum mainnet. So basically we are sending to the Ethereum mainnet a StarNet RPC method, and we are going to get this error. Yeah, method StarNet chain ID does not exist or is not available, right? So what we need to do is to initialize this with the StarNet RPC endpoint. So we can come to slide 24. Here is the StarNet endpoint. And then we can initialize the RPC here, or as we did in the previous example, we can also initialize the provider here. So by typing this, set provider, and then putting the endpoint here. But in this case, I'm going to initialize that for the final developer in the usage file. Perfect. So let's do it here. Just remove. Okay, and then to call that web3.accra.starnet usage. And that's it. Perfect. We can take a StarNet chain ID, and then we get the hexadecimal value here. Then we can use the utils.begint, and then let's run it again. And then we have the started chain ID. And this is how you can interact with the other different custom RPC methods of the started. Any question with this one so far? It's also working for everyone? Perfect. Okay,
Can
now
you go back up to the first?
to the arbitrary.
Yes, the arbitrary.
Let me do a little. Yeah. Is everyone on the same page, or any questions before we move on? Yeah?
Yes, availability.
No. And to see the parameters, I put the link here, reference startnet, and then you will see here. Startnet chain ID RPC method returns the currently configured startnet chain ID, and then the parameters here. This method does not accept any parameters. And then here is the example of the raw RPC code, and then you can see that it's empty parameters. But some of them, let's see, for example, get block with transaction hash. So this one returns the block information, including the transaction hashes, blah blah, and then you can see method, started, get block with hashes, and then parameters latest, or any other ones, the block ID in this case. Yeah, and then here you can see all the different other RPC calls. Perfect. Any other questions? Okay, we'll assume we are in the same page. Oh, the code, yeah. If something isn't working, don't be shy. I can go and check if something, if you're getting an error or something. I'm a friendly guy. Now we are going to do the most interesting part. So we built this thing, right? So how we can make other people to use our plugin. So we are going to go to the package.json, and we are going to give a name to the plugin. I will call it 0 to that dash test, right? We are going to publish this so other people can use it. So what I'm going to do is, you will get something different than me because you will need to set up your npm account. But here, in the console, I'm going to type npm publish. And it will just ask you to go to the npm, create an account or something like that. And then as you can see, it's already published, the 0 to dash test. Then I will come to npmjs.com/package/0 to dash test. And our plugin is here, right? As you can see a few seconds ago, I'm the creator here. And then let's make like a simple getting started guide. So I'm going to create a README here, then just getting started with our plugin. And then I'm just going to copy paste this this usage here. Then remove the comment. Perfect. Okay. So what happened is that I just updated the README. I'm going to show you. Yeah, but it's fine. At the end, this is just the guide, because when we are calling the Arbitrum, remember that in Arbitrum, I'm setting the provider internally. So even if the user initialize the plugin with the startnet, when you call the Arbitrum, this will set the provider to Arbitrum. And then when you call the startnet, it will be connected to the starting one. Perfect, because I already published this without the README, so now I need to update the version. So I will put version 1.1, then make a change. Then I just type npm publish again to publish the version 1.1 of the plugin. Just wait a few seconds. And then you can see here in the README, our getting started guide, right? And then what happened is that all of you can go and install my plugins. So let's actually use the same thing here, the same file, the same folder. So I'm going to type npm install 0 to that.
Sorry, one quick question. I want to know why I changed the name from 0 to dap to 0 to dap test. Wouldn't that have any, wouldn't that cause any issue?
Well, what? I didn't get that.
So you changed the name to 0 to dap
Dash test, yeah.
in the README file.
Yeah,
That doesn't, or that's just for the README.
that's only the README, yeah.
Thank you.
This one. Oh yeah, this, yeah, because this getting started guide is something that, for example, I want you to copy paste and that it works right away. So normally here it was ./index.mjs, but when the final developer is using that, the file will need to import this from the package. So that's why this is the name of the package. I'm going to show you right now what I mean. So look, let's say that we are a developer user. So developer user.mjs. We are using the package now. And what I want you to do as a developer user, oh, I didn't install the package. First we need to install the package, so I'll just copy paste this. Then we'll see in package.json 0 to that test version 1.1, right? And then why I change this is because I want to copy paste this here and that it works right away, right? Because before we have the index.mjs, but if you check your computer or whatever, like your folder, you will not have this in index.mjs. You will have this in the package 0 to that test, right?
So like when did you create the package 0 to dap test? So
Oh yeah, but this is just like a documentation, a getting started guide.
So it doesn't exist, 0 to dap just doesn't exist. I'm not getting it.
Like, let's say that it's like that, right? Or what do you mean? What is the?
I'm just confused as to how that exact name came about. It's going to be necessarily create that.
Oh, because this is the name of the package here.
Oh,
So this is the name in my package.json. If I call this, let's say, -jesse, and then I change the version 1.2, and then I just npm publish again. Let's say if this will work, if this will actually change the name. That's a good question. That will change the name. Yeah. So then as you can see, the 1.2 version. So now if I try to copy paste this will not work. Because we need to import this from 0 to that test-jesse, right? So that's why it's this name here. This is the name from where you are kind of importing the plugin.
That's it. Here's your question. Does it override the version?
Sorry?
Does it override the version? If you publish a version 2, version 2, does it override?
Oh yeah, that's true. Yeah, because that was like how is that called? Break changing something, but then we need to put version 2 here. But yeah, like for this example, yeah, that doesn't really matter. It's just to kind of show you the name, where the name is coming from.
On the npm platform, does it override the
you
previous version?
don't have access to the play version.
Oh yeah, you can.
You don't have
You can have access to both, to the 0 to that test and 0 to that test, Jesse. You can access to both. Yeah. Yeah. Perfect. Now you know how to make the plugin, how to publish the plugin and everything, right? Is there any question?
Mostly does your package need to be verified by npm, or anybody can just do it without any verification?
Good question. So what is a good practice is that you can come here, the package.json, and then you put, how is this called? There's something here. I forgot how is this called. Repo. Yeah, repository. So the repository field, and then you put the URL or the repo, right? So let's say github.com something like the rep. Then let's just publish this again. So this doesn't have to be verified, but at least a good practice is that the code of like the GitHub code is pointing to the plugin, right? So you will see here in the right the repository link, and then you can go and check the code of the plugin. That's like a good practice, right? And then the next step is, okay, I created a really cool plugin. Now we can go to web3js.org/plugins, and then you can publish your plugin here as well. But that will be the idea. If you create something really nice, that other people can also see your plugin here. So how you can publish your plugin here? You can go to the web3js GitHub, and that will be here in landing, web3js landing. Yeah, in landing we have, I think that is SRC plugin list. So in SRC plugin list, you can just add here the name of your package. So in this case, I will put here name, 0 to that, -test, -Jesse, is featured false. Yeah, that's just kind of by default, and that's it. You just need to make a PR to publish your plugin here, and then it will be published here. As simple as that. That's the whole, I mean, we'll review it. We'll make sure like what is the code that is not doing something weird, and then it will be published in the Web3.js website. Yeah. So that's basically the whole process of creating the plugin. I will actually like skip the CK sync. CK sync is the same, but we are just calling the CKS_get_key parameters, and the same with the Polygon CK EVM. Yeah.
So you need to write documentation for the plugin before it's actually.
At least the README. So if you have a README here with the whole thing, for example, this namespace plugin, the only thing that you need to write is the README. So for example, if you check the namespace plugin, you will scroll down, setting up the plugin, how to work with this, blah, blah, but just the README, not the whole documentation.
So on the Web3.js docs website, does it provide documentation of the plugin?
Here in the Web3.js documentation is only about Web3.js, not for the plugins. Yeah, this will only cover the Web3.js package, but not the specific plugins. Yeah. The plugin will be only in the README. Perfect. Any questions so far? Okay, so now I have a question for you guys. We have 30 minutes, and we have two options. We can make a plugin for MetaMask, or we can make a plugin for Chronicle oracles. You choose one of them. The MetaMask is really similar to what we did, because instead of making it calls, we are making, let me show you. We are making calls to the JSON RPC API of MetaMask. So it will be really similar. The only difference is that we are putting wallet_add Ethereum chain, or wallet_get permissions. So I mean, like here in the method, you will put the MetaMask, but this is only to be used in the front end. So that's like a front end plugin. And then the other option will be to create a plugin which interacts with the smart contract in Chronicle, like the Chronicle oracles, to fetch price assets. So you choose. Who wants to do the MetaMask plugin? Raise your hand. Who wants to do the Chronicle plugin? Okay, let's do it again. Chronicle. 1, 2, 3. Okay, who wants to do the MetaMask? 1, 2, 3, 4. Okay, then let's do MetaMask. maybe we can do both. Let's see if we have time. Okay. So for the MetaMask, this is the code. Yeah, I can send you the code. Or the other option is, I already have a MetaMask plugin that I actually created because it's easiest to use. I can just walk you through the code of the MetaMask plugin as well. That would be actually similar. So actually I created this plugin a couple of weeks ago, and it's called web3-metamask-plugin. And then let me walk you through the code, which will be easier to know. This is what is in the README. So import web3, import MetaMask plugin. We just create an instance of the web3. This window.ethereum is how you interact with Web3 from the front end, so in a React application, then a new instance of the MetaMask plugin, and then here we have all the methods for the MetaMask plugin. Connect wallet, disconnect wallet, get permissions, request permissions, etc. These ones are really good. They switch to Ethereum. So when you call this function in the plugin, it will trigger the MetaMask to switch the network to Ethereum or to Sepolia. I only implemented this tree, but you can even implement more.
That's Seckles, right?
That's what?
Seckles. Genosis?
Yeah, Genosis, yeah. But then you can add even more. I just added those three for open source, yeah. Everything is here. You can, I created that kind of for fun, but you can contribute for sure. So let me just walk you again. Import Web3 plugin base, as we did before, and then the ETH module as well. We created the MetaMask plugin here. Plugin name is Play MetaMask, so the developer can interact with the plugin using MetaMask. And then the first function that we have is connect wallet. So when you call the connect wallet, this will trigger the MetaMask pop-up in the front end, and then we'll ask the developer like, hey, connect your account. I could create a React app really quick, but yeah, maybe not. That would be, maybe you can do the Chronicle one. What we are doing here is sending an RPC call, which is ETH request accounts. So this .request manager.send ETH request accounts, and then this will trigger the pop-up. The MetaMask will show you the accounts. You will select one account, and then when you select one account, this will be stored in this variable in an array, right? And then this will be just returned. So this is the first connect wallet. We are just calling ETH request accounts. The second one is this connect wallet. This is just really easy as well. The same thing. This.request manager.send. Then the method that we are using is wallet_revoke permissions. That documentation of the RPC is here. So if you see, for example, revoke permissions, they have the example here. Method, wallet revoke permissions, params, you need to send this. I don't know why this ETH account is empty, but you just need to send this. Here is window.ethereum.request, but because we are using the web3.js plugin, I have this .request manager.send. So basically it's the same here, just this. It's just more RPC calls, right? Then the other function that I have is switch to Genosis, right? So this switch to Genosis, same is an RPC call, but this RPC call is called wallet_add Ethereum chain. So all these wallet_RPCs are always kind of triggering the wallet in the front end for the user, right? But then this one has a lot of params. You were asking for params before. You can see all the params here. Let me go to the MetaMask to show you that here. Switch add Ethereum chain. Show you. So add Ethereum chain, we have all these parameters: the chain ID, the block explorer's URL, the chain name, icon URL, etc., etc. And here you have the example of the code. You can literally just copy paste this, and then if you want to do the same for a different network, so you just need to change the different parameters. So Sepolia, the chain ID of Sepolia, the RPC URL of Sepolia, the icons, etc. ETH here, ETH, the block explorer of Sepolia. And then when the user called this switch to Genosis, basically you will switch to Genosis network, right? And same here. Switch to Ethereum. As you can see, we are calling the wallet_add Ethereum chain, and then the native currency is Ether, symbol, RPC URLs, etc., etc. And then the same with Sepolia. Same method, wallet_add Ethereum chain, and then the same things here, block explorers, native currency. So basically, you can make a SDK for MetaMask. I have it here, but only with 5 functions. But then you can implement all the different functions here for MetaMask, and then that's like an SDK for MetaMask, right? I think like the most important is to connect the wallet and to switch to chains, because that's like a really useful thing that everyone always does, always needs to change a network. And you don't want to send all this code. You don't want to have all this code in your front end to be able to switch to a chain, right? So just by calling this function, that's done with the plugin, right? Any questions with this MetaMask plugin? It's simple to understand. It's the same thing that we did, just changing the method in the RPC call and changing the parameters. Clear? Perfect. You can also use it. Actually, use that when creating dApps. Is easier to connect and also to switch to different chains. So that's one of the main use cases to create these RPC calls. Okay, and now let's do the Chronicle one. I never done this plugin before, so let's see if this works well today. This is my only slide. The only slide that I have is this testnet addresses of the Chronicle, and then let's just create a plugin. Let me just remove this. The idea is to share this code with you as well. So yeah, put it here. I'll call it 0 to that. Okay, and then I will put another one 0 to that Chronicle. Okay, so we are going to create a plugin. Maybe I will go a little bit fast in this one, a bit faster. We only have like 20 minutes left. Same thing, npm init-y to create a new project. Then install the web3 library, npm install web3. I will create the index.mjs. So here we are going to have the implementation of the plugin, import web3 plugin base from web3, export default class, let's call it Chronicle plugin, extends on the web3 plugin base, the plugin namespace, let's call it Chronicle. Perfect. Here is the same thing that we did before, created a class which inherits from the web3 plugin base, but now let's create functions that interact with the Chronicle oracles to retrieve price feeds. A price feed is when you call a smart contract that will give you the price of an asset, like Bitcoin in USD. So let's actually do BTC USD. Let's do ETH USD, and then let's do Sol USD. Perfect. Yes. Okay, what we need to do here is to import the contract package because we are going to interact with the smart contract, right? So the first thing that we need to do is to initialize a contract. Let me just put the comments, initialize a contract. So we need to type new web3 new contract. And then we need two things, the ABI and the address of the contract. So to get the ABI of the contract, I will come, let's say, to BTC USD. Okay, let's go to this one. All these smart contracts will have the same ABI. So with one ABI, you can interact with all the different, because you can see that every smart contract has a different address, but they share the same ABI. So I came to the BTC USD contract. I will scroll down to the ABI, contract ABI. I will copy the ABI, and then I will just create ABI here, ABI.mjs, ABI, let's call it Oracle ABI. I just copy paste all this long ABI that is huge. Then I will scroll down, okay, it's huge. And then export default Oracle ABI. Perfect. We will always need an ABI to initialize the contracts. So what I need to do is to import the ABI here. Oracle. Where's the one? Why not showing? Okay, let's try. Perfect. So I just imported the ABI here. Hopefully it will work. If not, we'll get an error. And then the second thing is that we need to call the BTC USD contract, right? So the address of this contract is here. I'll just hard code it here. Perfect. Any question with this line of code? We are just creating an instance of the smart contract, so we are able to interact with the contract. And then here we can call the contract. So to call the contract, we just type the instance, which is contract.methods. And then we need to see the method that we are calling. In this case, let's go here to the contract. Because we don't know what is the name of the method that will retrieve the value, right? In this case, because I already know, is this latest answer. So when you call the latest answer function, this will retrieve the latest price of Bitcoin. In this case, this contract, right? So we just type contract.methods.latestanswer.call. And this is how you call the contract, this specific function. Then let's just store this here in the result variable. And then let's see. BTC price is, and then the result. Yeah, do you guys have any question with these 3 lines of code so far? First, we need the ABI and the address of the contract. Then we are interacting with the latest answer method. In the smart contract, we are making a call to that function. And then here we are just printing the result, which hopefully will be the price of Bitcoin. Something really important is, as Joel was saying, we need to initialize a provider here, right? Otherwise, how do we know which network we are calling? So that's why we need to put here, let me put like, how is that called? I don't know, I forgot the word, but link context, yeah. So what we need to do is contract.link, and we just type this. So basically what we are doing here is, based on the RPC that the developer is registered in the plugin, like kind of link the contract context to the Web3 context. So I'm going to show you that here as well in the usage. So this usage is how the final developer will use our plugin. So we need to import the plugin, Chronicle plugin, then we need to import the Web3 library, then register the plugin and RPC endpoint. Okay, so here we are calling these testnet addresses in Sepolia, so we need to initialize this with a Sepolia RPC, right? Otherwise, it will not work. If you make this call to a mainnet, you will get an error. But then I will come to Sepolia, scroll down, and make sure that you're getting this from specifically this network that is called Sepolia, only Sepolia. I'm going to get this one. What happened? We are creating the new instance of the plugin here. And now we can use the plugin, right? To use the plugin, we need to call the BTC USD function with this name, Chronicle. So I'm going to type web3.chronicle.btc USD. And then let's see if this works. I think we need to put this in a same function. Okay, and then let's see if it works. So we just type node usage. Okay, let's see what we get. Can be an error here. Maybe the ABI. Let me just print the ABI. That happened, we try to improvise. So let's see if this. Oh, it's actually in the ABI. So what is the error that we are getting? We are talking to Sepolia. We just change the network. A lot of X here. Wow. Maybe this one.
As in video. Yeah.
Trying to see what can be run here.
Yes.
Oh, okay, it works now. Yeah, so as you can see, I just changed the RPC again. If something is not working, just change the RPC URL. And then as you can see, I just call it here, the BTC price is this thing. And then if you want, we can just format this. Const formatted price. Okay, perfect, that's great. Result to a string. Substring. 0.5. I'm just formatting the price here. Let's see this one.
So then how do you show that these are going to be created? How do you show that they have been created? all the plugin in the index instead of the usage.
The thing is, this usage, like here is the creating the plugin. This usage is not supposed to be here. This usage is like if I'm a developer that installed the plugin and is using it.
Yeah, and I was saying, so for example, we initialize,
Oh, the RPC endpoint, to put this inside the plugin. That's
probably ensure that it's constant, because you realize that sometimes this will work, and sometimes it doesn't work, you have to change it.
because the good practice actually to use like a quick note or Alchemy or Infura RPC endpoint, right? In this case, because I'm doing this workshop, I'm just taking this for free in chain list. But if you go to Infura, let me show you.
Okay, so they are stable endpoints.
They are stable, but you have a limit. You have a limit of, let's say, 100 calls a second or something like that. But that's the thing, when you create like a DAB or whatever, you will need to buy an account or something. But that's the thing, when you create the plugin, you don't need to care about that. It's the developer that is using it, or the project that is using it, the internet that will care about the endpoint, right?
So it's best practice to not initialize the endpoint in your flow.
In your plugin, no. The best practice, we're getting an error again from this. Let's see if we can. So yeah, let me show you the Infura endpoint. Because they give you like a private key that you can call a specific endpoint in Infura. Then after this, I'm going to walk you through the code again. It's taking some time. And then I will also tell you, we'll be the first one knowing about the web3.js bounty that we're having for the hackathon. We'll just give you like a quick overview of that. Wow, it's taking a long time. But yeah, my whole point is that you are able to understand how to create plugins, which type of use cases, one is the RPC calls, this one is specifically interacting with the smart contracts. Create one here. Create.
So you're able to get one from here. Does that mean you can then initialize your usage?
Yeah, just we are making sure that it will work. So, but at least we are using one endpoint that is not crazy. So yeah, as you can see here is like the private key for my endpoint using Infura. Perfect. And then it worked. BTC price is this, Sol price is this, ETH price is this, and so on. And that's, in this case, we are using only one plugin and calling 3 different smart contracts. But if you are doing that manually, you will need to basically do this in your front end or in your DApp or whatever. So that's why the plugins are really useful to create developer tools, because you can create a plugin to retrieve all these values from Chronicle oracles, for example, right? I don't know if you have any questions. I will walk you again through this code. I'm going to also publish that in GitHub. But yeah, basically importing the Web3 plugin base and importing the contract package from the Web3.js. Then the ABI. Remember that every time that we want to interact with a contract, we need an ABI. Then creating the class, which extends from the Web3 plugin base. Putting a plugin namespace here in this property, in this case Chronicle. And then what we are doing inside this function is, first we are initializing the contract by typing new contract, which receives the ABI and the contract address as a parameter. It's the same line in all the different functions. We are just changing the contract address because this contract address is pointing to the BTC USD. This one is pointing to the ETH USD. In this link context, we are basically telling the plugin, hey plugin, you need to use this context. And the context in this case is this endpoint to talk to Sepolia. Otherwise, the plugin doesn't know where it's making the call, right? If I, for example, comment this, and then we try to use it, we'll get an error. That is like a provider not available, because we are not setting any provider, we are not linking the provider in this function. So that's what we are doing with this contract.link. Then to make the call of the contract, we just need to use the contract instance, in this case, contract.methods.latest answer, because we are calling that function in that smart contract. .call. And then we are going to store this result here. This is a big int of like 18 numbers, 18 digits. So that's why I have these to a string, a substring, just to get like the first 5 digits, and then just printing that in the console. Any question with this function here? The thing is, we already have a plugin for chain link, right? So that's why I didn't do the chain link, but it would be literally the same. But the chain link, yeah, because you missed the version that we have on Saturday. We actually use that plugin. Everyone is already aware of that plugin. But it's the same. It's doing the same. You are just calling a function that is called getPrice and specifying the pair that you are calling, but it will be the same. Literally the same thing. And you can do the same with other Oracle, and then you can check if, for example, Chronicle is giving a bounty for creating developer tools or whatever. You can make this for them, and then you will get something. Or the same with other oracles. You will just need to check. There are some protocols that offer bounties for creating tools or whatever.
So apart from current prices, does Chronicle also show like its historical prices of your BTC?
Ooh, I don't know. But that's a good question.
Because I realized there was an issue with chain.
With Chainlink, it's just the current one. Yeah, that would be. I'm sure they should.
Can create plugins.
Maybe that also does more things. This plugin is to fetch prices, but you can also make a plugin to interact with Uniswap, or a plugin to interact with any other DeFi protocols, any other bridges, or whatever. So that's why I wanted to show you this example of creating a plugin to interact with the smart contracts, and then you can just kind of abstract all the different contexts of these things into a function that the developer will use in a very easy way, right? And then you can also add any parameters here, and yeah, that's everything with that. Yeah.
Is it possible to link contracts with other? Okay, each function has a contract or link, so you can link it to other RPCs.
As a provider. Yeah, like another network. Yeah, let's say that this one we are calling. Let's say that this contract is in Arbitrum, right? So we have two options. One is set provider in the index in the plugin, right? Like as we did before, which be here like this. Right, but then this is not the best because then this endpoint at some point maybe will stop working. That declines, so it will be saturated. Or the other one is that then you ask the developer here to also change. Because you can also change here like web3.setProvider, and then you can use it. You can change the provider like from the developer user, from the final user. Yeah, that's basically. You just need to make sure that the endpoint is connected or is calling the right network here as well. Right? Yeah, go ahead.
Yeah, I just wanted to ask the question he asked about the historical prices. The historical prices, I think that can be fetched. It can be fetched from the blockchain because the Oracle updates in the time period, so you can fetch the history of the blockchain.
I think then you know what you can do. You can fetch. You can when you are making this call. I don't remember how to do that. But when you are making this call, you are basically calling the current block.
Yeah.
But then if you have TX, let's say, I don't know if we can put null here. Yeah, if I put null and then the second argument will be the block. So let's say that I want to call the block, let's see if I can try to do something live. Let's see, this is the latest one, the latest block. I don't know if this should be null, but let's try. Okay, so then I'm calling Bitcoin. That's a really good point. Well, actually, let's put this here as a parameter. It will be easier. Block number. Perfect. So then BTC USD will accept the block number that you want to call, and then here we can call this block number, and then here we can call another block number. Let's put this. Oh, okay, so we got an error. We ran out of gas. Okay, so it fetches the first one, but it didn't fetch maybe because it's a really old block. I don't know. But basically that's how it should be, right? Oh yeah, maybe because it was a really old block.
Yeah.
So it was, yeah, I don't know. Maybe it's just, you can just call a specific like number of
Range.
posts in the flags. Yeah, specific range.
And you can create plugin to call like calculate the number of days, or like so maybe the number of blocks. So
Yeah, because you don't know how many blocks is like 1 week ago, right? You don't know that. But then you can do something like that. Yeah, I don't want to say like 1 million of blocks before. I want to say 1 week ago.
Yeah, and there's no like in the block it doesn't have like a specific time that each block is.
Yeah,
created.
yeah. In the blog you have a timestamp.
Okay, I don't know.
So you can call, yeah, so that's the idea, to just kind of spark that creativity, and you can create plugins for whatever you want. For common goods, for people to use, for a specific protocol, or whatever, but that was the main goal of today, to teach you how to do this. Then you can just become creative, do whatever you want, reach out to other protocols, pitch ideas, hey, I want to create this for you guys. You can make a quick MVP or whatever, and yeah, I just basically wanted to provide you with these tools. Really good point, Joel. Thanks for bringing that thing. Yeah, that with web3.js you can call specific blocks. Not by default, it's always calling the latest one, but then here you can see that we are calling a specific block number in the past. Okay, we are late, but let me just show you a couple of things, really important ones. Yeah, now let's talk about the bounty. For the bounty, I have here the 3 plugins that we are kind of having for this ETHAccra bounty, which is Swisstronic. Oh wait, yeah, take a photo with this so we can show it to Swisstronic. Let me just put this in full screen. Oh, she's not working. Wait.
I think the internet is off.
Oh,
So switch to ISA.
Isa.
but I don't have the other password.
Um,
Oh, this one?
Oh yeah, that's a picture.
Yeah, that's like that. Oh yeah, that's smart. Oh, you have it?
The one.
What is that?
It's opposite.
Guys, I always wanted to do this Africa tour since April, but it was a little bit hard to convince people, like, why you want to go to Africa, right? But then after they saw that I was going to other conferences and everything was working really well, I was able to pitch the idea again a couple of months ago, and it worked well. Now I'm here, right? But then from ChainSafe and web3.js, we only have like $3,000 in bounties. And because we have some plugins that people are building or projects are building, I was like, what if I tell them that I'm doing this and if they want to promote their plugins? So I reached out to all the different projects, and at the end, from 3K bounty that we have, we went up to 12K in total. So we are giving 3K in Ghana, 4K in Nigeria, and 4K in Kenya. So that's why, yeah, let's take a photo with the sponsors, whatever. That would be nice to show them. Because I'm, yeah, really grateful with them. That's why we have the money here. So Swisstronic plugin, Swisstronic is a layer 1, right? This is one of the easiest plugins because to interact with Swisstronic, you remember the data field? The data field here should be encrypted using Swisstronic library. That was really complex. That was actually my first DevRel job for Swisstronic. But then with the Swisstronic plugin, you interact with Swisstronic in a normal way, like interacting with Ethereum, and the Swisstronic library under the hood is encrypting the data field and doing all these things. But yeah, as a developer, you just need to use this plugin in the normal way, and it will work. Then the second one here, you have all the links to the plugin, whatever. The second one, photo here, CK Sync, they give 3K, so they are the biggest guys here. CK Sync is a layer 2. That is, it has a lot of different methods. This one is more complex one. That's why the bounty is a little bit bigger. But it's the same. Here is the link, web3.plugin-CK Sync. How to, you already know this, how to import the Web3, how to import the plugin, initialize the RPC. But then here, you send the RPC endpoint when you register the plugin. You have it here. I also have the link to the documentation of CK Sync, where you can see all this plugin documentation here. You take a photo with CK Sync?
Yeah.
that's an important one. Okay, and the final one is Aura. This one is really interesting, I really like it, because it's an AI on chain. So this AI on chain is, you are calling a smart contract with a prompt. So you can say, maybe if I have time in the order workshop at 3 p.m., I can do a demo of the 3 plugins. But basically you are sending a prompt, and you can say, create an image of an eagle, and then it will return, it will do the magic, whatever, and then it will return the prompt or something. They have 3 different models. One model is Llama 3, so this is text to text. This is basically like a ChatGPT thing on chain, on a smart contract. OpenLM is highly performant trainable. This is basically the same thing. Llama 3 and OpenLM will be the same. Maybe this is more trainable, the OpenLM, I guess. And the stable function is text to image. So when you use this text to image, it will basically return. Yeah, it will basically return IPFS hash. Do you know what is an IPFS hash? Perfect. So I will show you really quick. Because yeah, you cannot get an image on your console, right? But then you get a hash, and this IPFS hash. You have an example here in the docs. Yeah, you get this hash. So here the prompt that they have in this example is generate an image of an eagle that explores the world. So they are sending this, and then they get this result, this hash. But then how I can access, what is the image, right? So to access to this, you can type IPFS, I have it in break. IPFS.io/IPFS, and then the hash. IPFS is the interplanetary file system, for the name. And then you can access to all the different hashes by typing this thing. IPFS.io/IPFS/ the hash that you have. In this case, this was the hash that we have, that the Oracle AI retrieved, right? Like returned. So this is also a really nice plugin that we have. All these things are the same, just web3.js plugins. But then the main bounty is around these plugins, right? So what we have, for the ones that participated on Saturday, you are already familiar with this, will be the same thing, but then not using chaining oracles, but actually using these plugins. So the ones that we have will be CK-Sync plugin, but specifically using paymasters. Paymaster is a little bit complex thing of, you can allow users to pay the fees in a specific token when using a transaction, right? So that's why it's handled only for this dApp. Something that you have to know that is really important is the best is to do something that works. It can be really simple, it can be ugly, but that works. With some examples of Saturday, for example, some of the people make some mistakes with decimals, and at the end of the day, if I get a price of ETH and it's saying that ETH is 50,000, that's not working, right? So yeah, something that works is the most important, that using a transaction that you can pay in a different token than the CK-Sync, that works perfectly. If you need CK-Sync testnet tokens, let me know, I can give you. So yeah, this is specifically for paymasters. Then a general usage of the CK-Sync plugin is for 100. You can see all the documentation here. CK-Sync. When you go to the plugin, you will actually be here as well. The CK-Sync docs. Yeah, JavaScript, web3.js. Here we have all the plugin things, and you can see all the plugin usabilities here. So that's the first one. Then the Aura AI, so making a dApp using the Aura AI plugin, $500, and making a dApp using the Swiss Strength plugin, $500. Simple. Just that. Then you will also get this Git code that you can link to your GitHub account and your address, Ethereum address. We already have the first winner, which is Joel. I will announce the other 3 winners today for the chaining plugin that we did workshop on Saturday. And then here in this spreadsheet ideas, I have some ideas that you can use for all the different plugins. In this case, namespace and multi-code. And yeah, these 3 are not part of ETHAccra. They were already used for last weekend or Nigeria. But yeah, at least for these 3. CK-Sync, Swisstronic, and Aura AI. Some ideas, some Paymaster examples as well from CK-Sync. And yeah, I think that's everything for today. Yeah, you can follow us on Twitter, ChainSafe, web3.js, Santiago Debra on Twitter. You can check the plugins on web3js.org. And this is if you want to join the ambassador program that we have as well, which we already have one ambassador there. Yes, if you want to. Yeah, Kwaku already had joined our call on 2 days ago on Monday. And yeah, that's basically everything. Any questions? Okay, I'm really happy that you were able to kind of get the idea, the code. Yeah, Now it's about creativity, creating plugins for whatever you want. In this case, the bounty is not about creating plugins at all. It's about using the plugins that we already have. But I really wanted to give this workshop because I want to give you these tools and knowledge to be able to create whatever you want. And yeah, it's not only web3.js, you can also put other libraries to do whatever you want inside the web3.js plugin, and then anyone can use it. Yeah, basically that's everything for today. Thank you for coming, guys. If you need any questions, feel free to ask me around, and yeah, we'll be here and around. Amazing. Good feedback, something to improve? Everything clear? Okay, perfect. I will push the code of these things. Yeah. Now you can have lunch.
How do you get the API?
Yeah.
The API, you copy it from someone.
How what?
How do you get the API?
Oh, when a contract is already when a contract is already verified on ETHAccra, you can see the API there. Let me just go there. So I came here to the testnet addresses, right? And then let's say this one, Aave USD. So you come to contract. When you see this check, it's because the contract is already verified. And then you can scroll down, or just put like API here, and then you can see contract API. And then you can just copy and paste that, and yeah, and that's everything. Yeah, in this case you see 11 files here because this is like 11 smart contracts that are interconnected and inherit and whatever. But yeah, always you scroll down to the end and you will find the API there. When it's verified. If it's not verified, it will not be there. Yeah, wouldn't advise to interact with non-verified smart contracts. Perfect. Any other question? Oh yeah, you were saying something? Oh, I will put it on my Twitter as well. Well, you can find it here in github.com/ETHAccra. So this was RPC. Let's call it RPC plugin.